states consistently and accurately in the system. However, I want to show you this chart because I want to show you that not all the organization nowadays utilize the full potential of analytics. They don't leverage the full potential of analytics very well. In fact, I was looking at the article. It says a recent IBM study says 65% of business organizations are not yet using big data for business analytics. So that's why I'm here to sort of give you the motivation and the initiative. So before I move on to next, I just want to understand if anyone have played around with Spark in this room. Okay, well that's good. I mean that's why I'm here to give you the initiative. So the fact about big data is kind of funny. When people mention the term big data, people think about like social media, email, tweets, unstructured data. However, many analysts show that their big data initiative was really rely on the transaction data and the log data. So it's really what we are processing. So we should take fully benefit on using Spark on Z, on DB2, on LW, on Brew, even on cloud. So what is Spark anyway? So Spark is an open source project. It's not a product. So I try to use a very simple keyword. So Spark is an in-memory cluster computing framework. It's a framework. You can build a solution. You can build a Spark application to solve your business problem. You can have multiple use cases and use Spark as a platform to solve your business problems. It's all in-memory computing. All the data should reside in the memory as most time as possible. It's not a data store. So once the data is loaded in the Spark memory, it becomes immutable, which means it's not updatable. So that's the key part. So there's no ideas like IDA. You have to keep synchronize the data using CDC, that kind of stuff. So if you want to update your data, basically you just reload. Just keep pipeline the data into memory again. It enables highly iterative analysis for a large volume of data processing. So in the past, you have to write a complicated code for yourself for application to understand what you really want to achieve. But right now, Spark has its internal iterative programming system that can help you to simplify your coding. So it looks much straightforward now. It provides unified environment. So if your background is C or C++, Java, Python, R, which is really recently introduced in Spark, you can provide those. You can use those programming languages to write out your applications, and then store your data in the Spark memory. So that's very simple for different people's background. If you're coming from as a data scientist, if you are a developer, you are a data engineer, even if you are DBAs. It radically simplifies the process developing intelligent applications. Just like I said, the application that you develop is going to be very simple. And in the demo, I will show you the source code. And it actually provides a very simple APIs for you to load the data, do the ETLs, transformation, aggregations, very, very simple, very quickly, very straightforward. And that's the idea of Spark. You want to become very user-friendly environment. So Spark aims to address speed, ease of use, and complexity. So fast. Well, I was doing this project before. So before I was doing this Spark project, I was using Hadoop's MapReduce framework to allow some of the XML analytics. So load the XML data from DB2 into Hadoop, and for the later demo, I used Spark to do this exactly same achievement. But when I do the performance benchmark, I found out that the performance time actually the performance boosts up really fast. It's up to 100 times. The reason is that Hadoop uses MapReduce framework to split the data into disk. You have to do a lot of I/Os, so that causes a lot of latencies. Whereas in Spark, you pretty much just dump the data into memory, and all in memory computing, so it's really fast. It's also distributed too. Its ease of use, like I said, it supports multiple programming languages. Scala is the main one, C, C++, Java. Spark is a object-oriented. Every time you create a Spark object, it becomes object-oriented, no matter how you look at it. So it's Scala-based, it's object-oriented, and it provides functional programming language. For instance, R, recently introducing Spark 1.5, allows you to do some graphical analysis. It also provides Java APIs, some of the interactive shells. It could run on the standalone, so you can deploy Spark on your standalone platform. Which means that when you deploy a Spark on your in your environment without any cluster manager, your Spark master become the cluster manager. You can deploy on the mesos. So when meso uses meso master replaces Spark master. So what it does is when the job creates, and when the job is created and number of tasks is created along with this job for scheduling, meso cluster manager actually understand and actually can assign multiple tasks to which machine went to the slave nodes. It can deploy to Hadoop's Yang cluster management as well that use the Hadoop's configuration. So Spark supports multiple purposes. It can be a simple query, could be a machine learning capability, machine learning. It could even support a batch job processing as well. But it's not like our traditional transactional processing where you can do insert, update, delete, those kind of stuff. But you can do some simple SQL queries using SparkSQL, which I'll talk about in the next slide. So it provides SQL capabilities, streaming, and complex analytics using machine learning. So this is a brief history on Spark. Initially it was a MapReduce invented by Google, and then it was actually developed by Yahoo in 2006, and then the first paper was published. First Spark paper was published in 2010, and it was the first version of Hadoop. The first version of Hadoop is 2011, but that was actually the same version that Spark uses as a foundation. And then it evolves, and then it continues to evolve. IBM gets involved in 2015, and IBM actually declared itself as #1 contributor to Spark open source community, and want to become the #1 adapter too. We will actually provide our own system machine learning libraries. Other than the Spark, other than the machine learning libraries that Spark comes with it. So we actually add on to more functionalities to it. So Spark is driven by the Databricks. Actually, it's an open source platform. Everyone can make contributions to add new features to allow some of the new machine learning capabilities, or the Spark, or the SQL query analysis, map, join, group by, those kind of functionalities. We can make more contribution to it. Let's see. So why does Spark matter to business? So number one is Spark is very easy to access the data. I should mention that Spark is platform independent. No matter where your environment is at, on your Z, on non-Z system, it doesn't matter. Spark can be deployed to different platforms, and you can access the data very quickly and easily. In the later slide, I will show you how you can use Spark to retrieve the data from Z, from Linux on Z, or from non-Z platform. Spark allows you to develop a line of business application faster. Like I said in the earlier slide, you can write a simple application to do complicated queries, to complicated tasks. So it gives so it relieve a lot of burdens for the applications developers. And Spark actually learns from data and delivers in real time. Like I mentioned, Spark has the capability for machine learning, and they actually do the deeper machine learning itself by digest the data that it has been filtered or has been analyzed and put it into itself. And once another query comes in, it actually so the same query can be, so if you run execute, so in my lab, I was practicing some of the interesting facts. For the same query, complicated query that runs, the first time it runs for like 5 seconds. The next time, same query runs for less than 5 seconds. The performance runs better and better. And the reason why the performance runs better for the same query being executed at the same time is because Spark Optimizer has this produce some of the Java bytecode that actually optimize the query processing internally in the Spark Optimizer. So for the same query that you process every time, the performance gets better and better. So that's how Spark analyzes the data and remember how the pattern goes. And it allows the streaming too. So it allows you to deliver some of the real-time data analysis. So who uses Spark? I categorize into 3. So the first one is a data engineer. I think DBAs can be also considered as a data engineer because the DBAs also, they have to bridge up the application developer and data scientists and provide the infrastructure, right? And you have to create the right a platform for engineer to work on. So you provide, also data engineer, they have to provide they have to understand the data, right? You have to provide the schema, for instance. So that's the data engineer. Application developer, basically they just build analytic applications and optimize the performance and look at the queries or the applications and sort of like help to also leverage the machine learning. So like I said, Spark comes with its own standalone machine learning libraries. IBM also comes with its own system machine learning libraries for deeper understanding of the data. Data scientists identify the patterns, trends, and risk, and discover new actionable insight. I put a link here. I'm not sure if you can look at it here. It's IBM provides this cloud-based workbench that allow you to extract your data set from your maybe vSAM or the syslogs and sort of put it into a cloud-based data center for you to play around with it. So you can try it out. It's free. It's cloud-based. So this is what Spark looks like. So let's start from the bottom. So let's start from here. So this is a Spark core, where the main project actually delivered all the details. For instance, it provides the task scheduling, dispatching, IOs, and programming, abstraction, resilient data set. So this is where the memory stays at. This called RDD, resilient distributed data set. Those RDDs are immutable. Like I say, it's not updatable. So here is the engine memory optimizer, and you can load the data from data warehouse, mainframe, DB2, Z, database, Oracle, or Hadoop. So in March, so in the latest slide I'll show you, in March 2016, this year, the hardware folks from IBM actually enabled Spark being deployed on the ZOS natively. So you actually can deploy Spark on the ZOS and without any data movement for security purpose and performance purpose too. So let me talk to you on each one of the key component here. There's 4 the key component to the Spark. The first one is SparkSQL, which I like the most because I come from DB2. So I really like to use the SparkSQL to query my data, right? So what does SparkSQL do? It provides the further abstraction of RDD, which means that you create a schema out of on top of the RDD, do sort of a data mapping. So that's for the structured or semi-structured data with access to SQL interfaces and access to the data via JDBC or ODBC to the database. Spark streaming is suitable for ingesting the data in real time analysis. For instance, social media data or some of the real time data that you want to analyze, along with the history data. So I do have one customer who want to use the real time data from their mobile to understand their customers' geospatial data, where they are at, so the customer can, that's a credit card company, so they actually can feed in their retail promotional items for the shopping centers nearby, so they can promote some of the shoppings and increase their application transactions. Machine learning capabilities that Spark provides is one key component here. The machine learning, for instance, some of the advanced algorithm like correlations, random number generation for generating some of the data samples, classification, regression, decision trees to help you to make some better decisions on what the data pattern looks like for fraud detection, modeling systems, stuff like that. Clustering and others. GraphX, it's a graph processing framework that it was enabled by in Spark version 1.2 or 1.3, and then R programming language kick in 1.5 to sort of enhance the existing graphical analysis using R programming languages. And the beauty of using GraphX in Spark is that you're saving the data in RDD. You're saving the graphical data in RDD without doing replication, converting into a data format. So you have vertex or the adjacent to it. So all those data are actually stored as a graphical data format instead of into some kind of a binary format in the RDD. So there's no replication, and you can build an application on top of it using different functions. I want to talk about RDD because that's the key to the Spark. Because whenever you load the data becomes RDD in Spark memory. And so that's the basic unit of data. And it's immutable, like I said, it's not updatable, and it allows fault tolerance collection of element. Fault tolerant collection means during the RDD failure, meaning if you load the data in the memory and somehow the system couldn't read this particular address space. So what it does is it actually remove that address space, but it actually recovers itself by using other RDDs who can remember how this RDD was originally generated. If it was transformed from join or map or group by, the other RDDs in the Spark memory actually remembers it, so it can rebuild itself during the failure. So that's the fault tolerance. If the data in memory is lost, it can be recreated from the lineage. That's what I mean by that. So it's caching in the memory, and the data stays persistent in the memory as long as the memory stays up. And it could create a checkpoint. So there's no need to check the data validation, because once the data is there, nothing can be changed. So that's the beauty of it. And many database or file system can be supported, right? So you can support so the data type can be HDFS, it can be Cassandra. On ZOS, it's ZFS for the Z file system. So an RDD, it's actually physically distributed across cluster, but it's actually manipulated as one logical instance entity. So I show you here in the diagram that we have RDD names, but they actually partitioned into three RDDs in different distributed systems. When you run aggregation or transformations, Spark actually pick up different name subset from each data node for this name group. So it's physically distributed, but it's actually treated as one logical entity. by the Spark from the user point of view. SparkSQL allows you to write relational queries that are expressed in either SQL, Hive QL, or Scala to be executed using Spark. It has I should say that Spark SQL uses schema RDD. So right now we call that the data frame. The data frame actually uses a schema RDD to do some efficient work for the query analysis. It uses standard connectivity through JDBC or ODBC to reach the data from the different relational databases. And for accessing the data to DB2, we use a Type 2 or Type 4 connection driver to read the data from DB2. So in my demo, I will show you. I don't think you can see it because the thing is that using Spark, you have to do another preliminary configuration to do the setup. But once the setup is there, you just simply kick off the application. So on the application, you don't need to specify where you go, where your JDBC driver is at, because it's already configured in your system. So what you need to do is just using a very simple API to call. It's called JDBC RDD or JDBC connector to specify where the table of the DB2 is, and then just retrieve the data. Spark R, it's a R package that I mentioned. It's very lightweighted. It's introduced in version 1.5, and it allows user to interactively run jobs from R shell to the Spark cluster. This project was actually launched with the cooperation with Rocky Software to intentionally to support R on ZOS. So how does Spark and Hadoop fit into one picture here? So I put it here. So like I mentioned, on the bottom of this picture is where the data resides on. You can have a HDFS Hadoop file system. You have other file systems, for instance, the database, the DB2, Oracle, Teradata. So basically, you load it into RDD in the memory. So if you load the data in the memory, say from the relational database, the bottom line is it doesn't matter where the data comes from. Once it's loaded there, it's there. It doesn't matter if it's generated from a queries result set or it coming from a file system or so on. So you can run Spark Analytics against the RDDs in the Spark memory. So like I said, Spark relies in all the in-memory capabilities, so it runs very fast across different distributed clusters. You can result in more real-time capability for Spark if you're using Spark streaming. Pretty much cover a lot of stuff here, a set of libraries and functions for streaming, SQL, graph, and machine learnings. So, like I said in the very beginning, when people talk about big data, we don't think about transactional data or log data, but really it's really about the log data and the transaction data that we use for analytics. So we should fully utilize it and so move the Hadoop and Spark processing closer to the Z data, and we don't want to move the data off of Z platform or to any other like Linux on Z or any other commodity machines over the network. I want to give you a quick slide. So I guess many of you attend the Monday section, the keynote, and then maybe some of you attend the Justin's talk. So I steal his slide here to show you that, because I'm from DB2, so I want to show you that in DB2 we also provide some analytic tool in support for allow Spark running on Z. One thing I want to mention here is not only just 8.6 million inserts per second, although no index on the table, but we are allowing 360 million transactions per hour through RESTful Web API. So it can read, it can load or unload the data quickly, fast enough to pipeline data out of into the Spark memory. and this is the queries. DB2 in version 12, we have a very significant query performance improvement, up to 90% for the Sapphire, and up to 80% of WAS portal. IDA, I want to mention IDA because eventually it's on the roadmap for IDA to adopt Spark, because IDA is going to be Brew Mix eventually in the end of 2017, and I want to give you an early insight that once the IDA is on the Brew, we have the capability for IDA to enable Spark using the Spark extension. So right now it's a perfect timing for you to play around with Spark, and eventually once the IDA is on the Spark on the IDA, then you can start using it quickly without rewriting your applications and so on. And Z13, I want to show you this slide because it not only it supports 10 terabyte of memory, but also it supports simultaneous multi-threading up to 30% of more throughput. So it actually speed up a lot of parallel processing. And Spark actually allows you to deploy on ZOS, so you can dispense all the threads across different nodes in the same edge space. So how is Spark fit into the Z world now? So now, like I said, Spark is platform independent, but once you deploy into the Z ecosystem, you can use JDBC so you can use JDBC to read the data from DB2 for ZOS to IMS, or you can use Rocket Software's MDS mainframe data service for Apache Spark for ZOS. So those are the two ways that you can read the data. Spark is running on Z, it can be running on the Linux on Z, and you can have a downloadable, or you can get a direct download, which is a standalone Spark utility, Spark standalone packages. Or you can get a Big Insight version 4.1, which has the Spark embedded in that package. Like I mentioned, IDA is on the roadmap for Spark extension, and here's a link that you can download. It's open source, so it's free. Yes.
So on IDA, what are you enabling? Like ability to read IDA?
So eventually IDA is going to be Brew Mix. Right now, Brew is already enabled the Spark to be on the Brew because it's column store and it's allowed. So in yesterday's talk, I think Angelique talked about how Spark can be a Spark as a service on cloud. So that's pretty much the Brew base. So once IDA is switching to instead of Netezza using Brew, then Brew has a Spark extension to use, so you can write the Spark application on top of it. Yeah. So you can get the number of downloads for Power System, System S, X, System S, or ZOS. So basically, you can configure your LPOW as a Spark, basically. And in my next slide, I'll show you. Okay, so back in February 2015, ODIP, or the IBM Open Platform, Open Data Platform Initiative, was announced by IBM and other partnering companies. The goal is to advocate and enhance the state of Apache Hadoop and the core Hadoop stack on which all the suppliers can agree on. So we can come out with a package that it's an open source and open platform. We can allow all the customers to use it. It's free, and it was available in last summer. So this is the picture that includes all the packages along with this ODIP. So here's HDFS, MapReduce, uses Young cluster, and Berry cluster management to view your cluster to see how healthy your cluster is currently behave. And here's the Spark. So Spark comes as it's a standalone, but you can configure it in a way that you can have multiple Spark instances across different data nodes. So you don't need all those other functionality, because a lot of functionalities that's pretty much just sitting up there once you use Spark. Once you fall in love with Spark, you don't need any other tools. So like I said in the other slides, Spark is available, but this is for you to configure and deploy your environment, your system. You have a number of ways. So so in this slide, I'm giving you an example how you can use Big Insight to deploy the package into your system. It can be on the Power, System Z, and Cloud. So this is the way you can deploy. And like I said, in May, we have enabled the Spark on Z OS, and now it's either on Linux, Z Linux or Z OS, free of choice. And this is a diagram that I showed you yesterday for those of you who attend the panel session. So on this chart, you can clearly see that we're deploying a number of Spark nodes on the Z Linux. Those are clustered together. So all those Spark memories are shared within this Linux box. There are 3 Spark nodes deployed on the native Z. These memories are shared together in same address space in the ZOS. These 2 are now shared. That's a key part. Once you declare the Spark is in this address space and in this environment, the address space is locked, and the network is not. You cannot read the data from here or to here. Well, let me say that again. You cannot dispense your data across network, but you can share the. You can read the data. You can read the data, but not to process the data. So let's say if you have a name A, B, C, and D, E, F. When you run the applications, you can retrieve all the names from A, B, C, D, E, but you cannot distribute your A, B, C onto D, E, F until you read it and then load it again. So that's a key part. And you can distribute Spark on the distributed system onto Oracle database, for instance. I don't know if that's supported or not. So one thing I want to mention here is it's up to 100 times faster than Hadoop. It's all in memory. And using ZOS, if you're using G13, allows 10 terabyte data, so 10 terabyte of memory, which is awesome. So this is pretty much the overview of unified analytic platform for integration of Spark and Z. And this is a deep look into how Spark can be configured into the Z natively. I've been talking to a number of customers who really like to use. So I talked to a number of customers. They first initially, because Spark on Z was actually available this year, but we had some initiative last year. So they actually deployed Spark on the Z Linux. They like it, but once the ZOS version is available, they quickly move all the configuration into ZOS because they don't want to move the data. That's the whole thing. So you can use the Type 2, Type 4 connection, JDBC connector to read the data, load the data into RDD from DB2 IMS, or you can use Rocket's mainframe MDS to load the data into RDD and write application on top of it without interfering with the existing OLTP transactions. So what makes sense? So this is pretty much a reference point. You don't need to obey this kind of rules, but this is a sort of reference point. When do you want to deploy Spark or Hadoop on your mainframe or not? So I would say that if your data originates from mainframe and you want to keep the data there, you just deploy the Spark on ZOS natively and run transactions, because that's a security concern. Data don't want to be spread out on the network. But if your data is not originate from the mainframe, you can set it up into the commodity computer, cheap and fast, and it can scale out too. So this is one example on how you can use DB2 as a Spark data source. So DB2 is right here with IDA support and DB2 and the -DB, LEW. So you can read the data from DB2, load it into Spark. One thing I mentioned here is it's highly zip eligible. So IBM want to offer you a very aggressive modeling pricing model to protect your MLC pricing. So don't worry about the ETLs on ZOS. It's already covered. It's highly eligible. So it actually give you a very low cost resource consumptions on Z. Yes?
Which blocks of those are natively supported on Z?
Which block?
The blocks you support, I mean, is it just the
The
Spark?
whole block?
The whole block?
This is a whole package. This is a whole Spark package. When you download Spark, it comes with this package.
But is all the entire package supported on Z?
Yeah, yes.
Okay.
Yes, yes. The entire package is supported. So I give you this as a very naive use case. Say if you are a financial manager, if you store your data in say DB2 for ZOS and maybe open source some of data in the open source platform like HDFS or Hive or Cassandra, you want to generate a business intelligence report. So what do you do? So first, if your data is right here in DB2 or maybe in the IDA table, you basically use the JDBC access to load the data into the Spark, and you convert that into a data frame. And once it's loaded into a data frame, it becomes an RDD method, and you can start using SparkSQL to access those RDDs to run some queries, for instance. This is another way to look at it using IMS as a data source. The only difference, so they're using type 2 connection to load the IMS data. So I put the picture right here. So it hypothetically, conjunction with the previous slide, you could load DB2 data frames from previous transactions, and then you can load IMS data frame into the same for different transactions. So now you have two different types of data frame. Does that really matter? No. Because once the data is there, it doesn't matter where the data is coming from. So it doesn't matter if it's IMS data frame or DB2 data frame. It's all data frame for you to analyze. So in summary, I just want to pick up the number of key points here. Some of the people just say that Spark is distributed system, so what? Well, it's not only distributed, it's all in memory. So that's the key part. You want to have enough memory for you to enable fast query or fast analysis. There are a number of ways that you can configure your system using Spark and Z. We're bringing a lot of SQL users and non-SQL users to this Spark now. So now it's the fun part. I want to show you the demo, the project that we did back in the lab. It's how we can incorporate this using DB2 XML table. We pick XML table because, so this is actually a real use case study. It was a requirement, the IFE from one of the customers from the tax agency, the governmental tax agency. They actually store about 400 terabytes of data, there's a taxpayers' profile information in XML data. They want to analyze it, but they store the data, 400 terabyte data in the DB2 using pure query or XQuery. It runs very slow, and some of the query there was a PMR is about running for over 24 hours, and it's not sustainable. It's not operational. So we were thinking, is there any way we can use some of the high tech to solve this kind of problem? So, like I said in the beginning, initially we used Hadoop. There's some problem with Hadoop, but for Spark, it's really, really good. So the customer really want to achieve, so first, no impact to the existing OLTP. They want to run OLTP, analytic processing. And they want to do some real-time analytics. And in fact, some of the tax information, like we all know, it's history data. So once the data is loaded, so it's a perfect match for Spark, because once the data is loaded on Spark, it stays there. So for history data, you don't want to change it too much, right? You don't want to wipe out your previous tax paper. So the approach here is to use JDBC to load it, like I said, to load the data from DB2, put it into a Spark, do some ETL transformations, and run some aggregations, and put it into some kind of a format that SparkSQL can run. So why we pick XML? Again, XML, processing XML in DB2 today is very CPU consumption, very CPU intensive, consumes a lot of resource, and it's not very feasible to run aggregation and analytics in DB2. And for large and complicated queries, it consumes a lot of memory and disks. And for very large and deeply nested XML nodes, the problem just gets worse. And for a lot of time, when you process XML, you have to scan a whole table, and that could be a perfect match for IDA. You might think, because pretty much you just scan through. But the bad news is that IDA is not XML supported, and not even LOB supported. So you have to find some way to figure this out. I might have missed one thing. Yeah. So there's no such way. So we use Spark. Using Big Insight for Apache Spark. The idea here is we sort of push all the heavy lifting data processing outside of the DB2 and run ETLs outside of DB2, but still on ZOS though. It's zip eligible, so we don't really care. So once the data is outside DB2, we can run some analytics and the aggregation. We use a function, so we create an API called the JDBC RDD to read the data from DB2 into Spark memory. And I mentioned that it's not HDFS or any other file system. So we don't need to manage. So as a user of Spark, we don't want to manage where the data is going to be stored, because Spark is not a data store. It's data processing, data analytics. So let the Spark optimizer decide where the data is going to be. But you still have to have some kind of foundation infrastructure to host your data, because you have limited size of memory. And once the memory reach to the heap, to the max, you have to swap out some of the data, allowing Spark to load more data into the memory. And we use analytic pipelining mechanism to extract the data, do some data mapping to normalize the XML, because XML is so much structured than node, parent node, child node, and so on. So we have to transform the records into data frame, so allow the SparkSQL to run, allow some queries to be processed. Now, in this project, we actually use Zeppelin or Notebook. We didn't use Zeppelin at the time because Jupyter was not available by the time we launched this project. But it's the same purpose. Jupyter, Zeppelin, they will have the same purpose to allow users to visualize the data, to see the data result. I'll show you in the demo. It looks very, very, very nice. So this is the overall picture. Okay, so this is overall picture of how it was configured. So initially, back then, we don't have Spark on Z enabled, so we use Linux on Z. We load the data, we pipeline data into Z, into the Z Linux, and we have the Spark installed on Z. So basically, it becomes the data frame in the Z Linux box, and we can run some queries showing on the mobile or showing on the OLTP front end here. And the OLTP is continuous run into the DB2. So the way it works is we load the data and map into the Spark memory. So I put it into here. The only thing I want to mention here is that, like I said, we want to let Spark optimizer to decide where the data resides. Most of the time, Spark optimizer is smart enough to put all the data in the memory. But once the memory reaches to the memory heap, it automatically swap out to the disk. So you have to configure yourself. So on Spark ZOS natively, you have to configure in ZFS. If it's on Linux, you can configure HDFS or Parquet or Hive table. So once it's there, you can do the mapping and then run some ETLs, transformations, load the data frame, and execute the SQL statement. So the sample, I couldn't get a text file, taxpayers information from this agency, so we use some of the online tools. So we find out that there's a Organization for Economic Cooperation and Development. So showing the employment rate of European countries by the gender and the age. So we load that into XML table into DB2, and then we pipeline into the Spark memory. So here is the idea. So initially we have the table here in DB2, and then this is what it looks like as an XML file. As you can see, it has age, gender, nation, and employment rate actually. And then we load it in. So this is the Spark. So this is XML. We load that data into Spark, and sort of pass through and convert that into, normalize it into this kind of format. So it becomes schema now. It becomes some kind of schema-like data frame. And then with that, we can run some queries. So, okay. So now I'd like to show you. Do I still have time? Okay, thank you. So this is basically what I presented at the SVL bootcamp. So first, I declare a pseudo class for the schema. It contains the country, gender, age, the time, which is the divided by the quarter, because it's the employment rate in European countries. You have different time. It's based on season, and this absolute value is the employment rate. And here is the URL to get to the DB2 table, and some of the credentials. Please don't remember my password here. So here, I put a comment here for you to understand easily. So first, you use this JDBC function API to read from this table. This is XML table. You load it into this variable. This is not just a variable. This is also RDD in the Spark already. So once you execute this line, Spark opened up the connection to the DB2. It opened up the connection, and then actually it partitioned. So the table is very big. It actually partitioned by the range. You actually do a table partition range and extract the data by the number of sockets, actually, number of connections, by the way. So I have a show. So I will show you the output later, but I want to show you the script first. So once I read it, and then I select a particular column, the first column. Okay, so there are two columns. The first column is the primary key. So you can allow Spark to partition your data set, so they can get the parallel fetching from DB2. So you want to have the second column, which is your real XML document. So you pass through using this mapper function. So this is actually a lambda function, actually, to get all the data from this. So read for each document, you read it and convert that into a Scala-like XML. One thing I have to mention that is that when the data is loaded from XML database into Spark, everything becomes normalized into a text file, because it's reading XML. It doesn't understand XML first, so it's really it's like a binary file. So you basically read a binary file, and you have to convert that binary file into a Scala-like XML. So Spark understands this is XML, not a string or not an array, a huge gigantic array. So once it's loaded, why don't I show you the result so it's easy for you to understand. Okay, so here's the thing. So first, here's the result. So when you execute it, you actually remember this UR is the table destination. This is the data frame. See, when you load the data, this XML record, it's the data frame. You understand it has two records. So this is two records, but the file is huge. The first column is the primary key. The second column is the string. It's not XML. So you have to load it and then do the lambda function to convert that into an array, which becomes an XML. So this is an array, right? So this is an array, but you use XML to use a scalar XML to convert the array into a XML-like. So this becomes a scalar XML format. And then you load all the records from all the nodes, and it's just extract the key values that you're interested to map to the class that you previously defined up here, the record. Because we only want to understand these key values. So once it's loaded, it becomes an array of records, normalized record, with the country ID, the gender, this is time and employment rate. Excuse me. And then you create the RDD, another RDD to, well, no, not to create an RDD. And then you create, so this is array, so this is an array of records. It's not data frame, it's an array. So you want to convert that into a data frame. So you do the toDF function. So now it becomes a data frame now. It understands that, okay, it's country, gender, age, time, and the employment rate. And then you can register that data frame into a table. So you just become like a DB2-like table in Spark now. I use cache. The cache function, it provides intelligence to cache all the data in the memory as long as the data lasts in the memory, Spark memory. The reason why we want to do the cache is because we believe this value is the most important ones. So we tell Spark that keep this data as #1 priority. If you want to swap out all the data because you reach to the memory heap, swap out other data, but keep this data in the memory. So we use cache. So once the data is cached, so you can now run SQL to find out, okay, what's the average of all the mans in this country, and it comes up with this value. You can, so this is Zeppelin, right? So you can visualize the data, say, okay, I want to see group by the country and the gender. I want to see what's the difference of the employment rate, and it's showing like this, and you can show in the charts, and you can show in this list, and showing all the difference of the employment rate across all the countries. Or you can print out using your, you customize it, the output as well. Pretty cool, isn't it? Yeah. So, yeah, so pretty much this is what we did back in the lab. We were now able to deploy the Spark on Z Linux, but right now I'm leading a team to deploy the Spark on ZVM, so we can try to scale the Spark as many as possible in the virtualized machine in the ZOS in the Z system, not the ZOS, but the ZVM. So we can provision some of the more Spark instances in the Z without consuming too much of the CPUs and memory. There's another demo that my coworker did back in the Poughkeepsie lab. They actually did a demo to federate the analytics using, so this is a credit card company's information. They actually store the credit card, each person's credit card information, stock buying information, the buying powers of each people. So the data stored in IBM DB2 and vSAN, they want to load it and put it into a Spark. So when you go when you bring your mobile phone to a certain places, it actually feed into some of the real-time data to your mobile phone for your convenience. And this demo is actually available on the YouTube, so you can download and watch it. It's very cool. Yeah, we made it available because it is open source. We want to hear more from you and see what your business problem is. We can help you to solve using Spark. Eventually, this is what the strategy and the tendency here. You use Spark as the Spark as service on Z, on cloud. So we really appreciate if you can give us some feedback as well. We can help you to deploy some of the, because the configuration, the difficult part, I have to give you some warning here. The difficult part for Spark, running Spark, is now. There's nothing to be difficult. But you have to configure your Spark in your system. That's the most the troublesome part. Because you may have different environment. You may have LPAS, and depends on the size of the LPAS. You might want to carefully determine what's the size of the memory that you want to allocate, where the data you want to put into, what's the memory address space you want to put in, because you don't want to overlap to your existing global buffer pool in DB2, for instance, right? So that can cause some of the storage overlay or some unbelievable problems. So this is my last slide. So like I said, last year, IBM declared as a #1 contributor and adapter in the open source community in Spark, and we have actually launched the Spark Technology Center based in San Francisco, and we just want to make sure that our customers are happy using the analytic, using the open source platform. And this is my contact information. If you have any questions, feel free to contact me. We are actually actively collecting a lot of use cases from customers, so we can go on site or we can talk to each other, or open up the bilingual dialogue to help you to configure your systems, help your business grow, and increase the application transactions. So I think I'm good on time, huh? All right. Thank you so much for coming.